Hello everyone, welcome to part 2, where we continue exploring the Search API. In the last video, we discussed that when searching for a document, you need to specify both the index and the query for the search method. To build more advanced searches, we use the query DSL, domain specific language. As mentioned before, query DSL helps create complex, structured queries. There are two main types of clauses in query DSL, leaf clauses and compound clauses. Leaf clauses target specific values within specific fields, such as match, term, or range queries. These queries can stand alone, which means that you can use, for example, just the match query or just the term query. But the compound clauses combine one or multiple leaf or even compound queries and allow for more complex logical combinations. So here you use bool. So for example, you can combine match and term, can combine multiple matches, etc. We will see some examples in the notebook. Let's dive into the leaf clauses. Let's start with the match query. Here you can see that it is in blue, which means that you can click on it if you want to read more in the documentation. The match query performs full text search and returns documents that match a given text, number, date, or even a Boolean value. If you want to use match, then the field must be mapped to a text data type. The term query returns documents that match an exact term in a specified field. The field should be mapped as a keyword or to a numeric/date type. For example, if you want to use term, you use it if you want to search for a book ID or a username or an email. These are values that are not repeating and you can consider them as keywords. Finally, we have the range query. This one returns documents where a field's value falls within a specific range. Now let's see some examples that shows you how to use these queries. Let's start with the match query. As I told you, you use the search method, you provided the index, after that you specified the query. So inside the body argument, you pass the query, and inside the query we have specified match. So here we are using the leaf clause. Inside match we are matching this text. So we are taking the field description and we are searching for any document that matches what we have here. So we have a description, which means that any document that contains this string will be returned. For term, it's the same thing. You just swap match with term, but this time make sure that, for example, product ID is mapped as a keyword data type. And here, for example, we will return any document that has this string. Finally, the range query is a little bit complex. I mean, it's not complex, but you just need to add more things. So here you see you used range, you specify the field, and here you have this means greater than or equal and less than or equal. To find these values, you just need to go to the documentation. There you will find what the range query expects. Now for the compound clauses, we have the bool query. This one combines multiple queries using Boolean logic. So here we have must, filter, should, and must not. This clause is used with fields mapped to a text data type. Let's see some examples to show you how to use this compound clause. Okay, so this one will be bigger because we will add a lot of things. Because as I told you, the Boolean query allows you to make complex queries by combining multiple, for example, leaf clauses or even compound clauses. Okay, so inside the query, so here, as I told you, use the search method, provided the index and the query. Inside the query, we will use the Boolean query, which is the compound clause. Inside it, we have must. Inside must, we have the first query. Here we are matching any document that has ElasticSearch in the title. After that, we are filtering any document that has status as published. Here we are using should, and finally we have must not. Now let's explain all these terms. So must, here we are trying to keep documents where title is equal to ElasticSearch. So must, it's like and in logic. Filter basically you will remove any document with a status of published. Should this match is optional. So if a document matches this, that's good. If it doesn't, no problem. So should is an optional option. Finally, we have must not, which means that we are excluding any documents where the deleted is true. Okay, so you use must, filter, should, must not to combine between all your queries. And here you can see that, for example, must, we have an array. So you could have inside must multiple matches, or you can have inside must match, term, and range. So you can make some complex queries. Here I am just showing you the individual components, but you can use them however you like. Okay, so this is all the things that I wanted to show you in the slides. Now let's go to the code to see more examples. Okay, so open the notebook number 13. Here you can see we have the documentation, and here I am pointing you to the query DSL language, because this is what we will use in this notebook. First of all, try to connect to the cluster, then insert some documents to the index. So here I am inserting those documents that are inside the dummy data JSON file. Great. So now let's do the search. So here I will start with the leaf clauses. Remember, here I am starting with term. And to use term, so here you can see that we are searching for a document that was created on 2024/9/22. And here you can see that we have just one document. Let's just verify if this is correct or not. So I have my dummy data JSON file, and as you can see, that's correct. So we have just one document that was created on this specific date. So here you can see that we have this hits dictionary that contains how many documents that we found. So here we have one, which is correct, but to get the document, basically you use hits again, which will return you a list of documents. Okay, and as you can see, inside the source dictionary, we have our document back. So it matches the document that we have in this JSON file. Great. So you can see that here with term, we are looking for exact values, but to do full text search, you use the match query. So here you can see that it's simple. You just swap term with match, and here you need to make sure that the field that you are searching for is mapped to a text data type. Great. And here we are searching for any documents that contains this string inside the text field. And as you can see, if I take this and search for it here, you can see that we have 3 results. And each one of the 3 documents contains this string. This is why we get 3 back. And again, you use hits to get your documents. Okay, so we have the first one, this is the second one, and this is the third one. Now let's move to range query. Okay, so here I am filtering the documents, and here I just want to get the document that is less than or equal this value. Let's see. So here we have only one document that is older than this value. This is why we get 1 back. But let's do 25. This should give us 3 documents. Great. Okay, so we have seen this. Cool. I hope that this is very easy for you guys, because you can use these leaf clauses individually, but here I am saying that this is how you use the leaf clauses. But if you want to combine multiple leaf clauses to make complex structured queries, you need to use the compound clauses. And this is what I will show you in this second part. So here I am showing you an example. Let's search for documents that meet the following criteria. Created on this date and have the word third in the text field. To use the compound clauses, you just specify inside the query that this is a boolean, which means that we will combine between multiple queries. First, inside must, I told you that you have an array, and inside it you can put multiple leaf queries. The first one is match. We want to match this string. And for range, here we said that it should be created on that specific date. And here we are greater than equal and less than equal this should have the same value. And this should return us just one document. Let's verify. If we search for third, you can see that third exists in just one document. But 2024/9/24 exists in two of them. But because we have these two leaf clauses inside the mast, here we are going to make an AND operation, which means that both of these queries must return a document. So if this one returns a document, but this one does not return a document, or if it returns a different document, then we will return nothing. But if both of them return the same document, we will count it as a valid document because it matches all the criteria that we have specified. Okay, so this is a simple example, but again, you can add as many leaf queries or as many compound clauses inside the bool dictionary to make more complex queries, as I said here. With the compound clause, we were able to combine two leaf clauses to find a specific document. And this is the power of using compound clauses. We arrived at the end of this video. I hope that it was helpful. Please, before leaving this video, leave a like and subscribe to the channel if you like. See you next time.